Imagine having a versatile tool used across various industries to preemptively recognize and resolve issues before they become larger problems. I mean, imagine a way to identify where and how it might fail and to assess the relative impact of different failures in order to identify the parts of the process that are most in need of change. Sounds great, no? FMEA, Failure Mode and Effect Analysis, originally developed by the military and now adopted by several engineering disciplines, aiming to help design products, processes, and services free of errors. And now, about this. So, Failure Mode and Effect Analysis, FMEA, is a structured approach used to identify potential failures in a product or processes. It evaluates the severity and likelihood of different failure modes and their potential effects, with the goal of helping teams prioritize mitigation strategies. But on this episode, I want to focus on the usage of FMEA in the context of DevOps and observability, as it can serve as a crucial tool for enhancing reliability and performance in software development and operations. Firstly, let's do a breakdown of FMEA key components. In the DevOps context, failure modes could range from code defects, infrastructure failures, to deployment rollbacks. Observability tools monitor systems to detect and categorize these failure types, often in real time. These are some of the ways in which something might fail. Failures are any errors or defects, especially ones that affect the customer and can be potential or actual. Then you need to assess causes and effects, where each failure mode needs to be analyzed to determine its root causes. For instance, a code defect might start from inadequate testing or developer error. The effects are then assessed. How does this defect impact the overall system? Does it lead to downtime, data loss, or degraded performance? This step seeks to identify the potential consequences of a failure on the system or end users. So now you do a cause analysis and identify each failure mode. In many cases, failure modes can have more than one cause. Here, failures are ranked based on severity, impact on the system, occurrence, likelihood of failure, and detection. Ability of the observability tools to detect the failure before it causes significant damage. Finally, prioritize action. Based on the rankings, actions are prioritized to mitigate the most critical failures first. This might involve refining code deployment processes, enhancing monitoring capabilities, or improving infrastructure resilience. So how is this applicable then, you might ask? Well, DevOps integrates development and operations to streamline workflows and improve productivity and system reliability. Observability is a key component of modern DevOps practices, which involves monitoring systems, gathering logs, metrics, and traces to gain insights into system performance and health. FMEA's role then is in threefold. With proactive risk management, FMEA helps DevOps teams anticipate and mitigate potential failures before they manifest in production. This proactive approach is crucial in maintaining continuous integration or continuous deployment, CI and CD pipelines, but also with enhanced observability, whereby identifying critical failure modes, teams can tailor their observability strategies to focus on high-risk areas. For example, adjusting telemetry to capture relevant data points that alert on potential failure conditions before they impact users. And finally, with iterative improvement, as new features are developed and deployed, FMEA processes should be revisited to reassess risks, ensuring that the mitigation strategies evolve with the system. Now, you can integrate FMEA with chaos engineering and simulation tests to proactively identify and mitigate new failure modes in a controlled environment before they reach production, or leverage AI and machine learning to predict failure modes by analyzing trends and anomalies in observability data, allowing for preemptive action, and even enhancing incident management frameworks with FMEA insights to improve response strategies and reduce recovery times during outages. Bottom line, in DevOps and observability, FMEA is not just about identifying and mitigating risks, but also about creating a resilience infrastructure that supports dynamic and continuous delivery environments. It helps in building systems that not only can hold failures, but also adapt and improve from them, ensuring high availability and performance. This proactive risk management approach is essential for maintaining the reliability of complex systems in a fast-paced DevOps setting. So by integrating FMEA into the early stages of product design or process development, organizations can ensure higher safety, improve operational efficiency, and achieve better user satisfaction. See you on the next episode.